Hi all, welcome to the another video on mathematics using technology. This is Ratnakishore. I upload videos needed for undergraduate students of electronic and computer science departments. So in this video, I present the basics of sets and their implementation using Python. A set is basically a collection of objects. Those objects are also called as elements. Let us consider some example sets. Set of computers, set of signals, and set of books can be considered as some example sets. Now consider an element E is present in the set A. Then you can write element E belongs to the set A. Here elements can be represented by using lowercase letters and sets can be represented by using uppercase letters. In the same way, if the element E is not present in the set A, then you can write element E does not belongs to set A. You can specify the set in two ways. The first one is by using tabular method and the second one is by using rule based method. In the tabular method, elements are explicitly specified by using curly braces. In the case of rule method, elements are determined by some rule mentioned in the two braces. So if you consider the example of tabular method, we have specified 1, 2, 3, 4, 5 as 5 elements present in that set. Coming to the rule method example, where we have mentioned the same set by using some rule here. That rule is integers from 1 to 5, which includes the values 1, 2, 3, 4, 5. A set which does not have any elements can be called as empty set, which is also called as null set. A null set can be represented by using a symbol 5, or you can represent the null set by using two braces without having any elements in that. So next I am considering a finite set. A set to be considered as a finite set if it is having countable number of elements in it. Empty set also can be considered as finite set. If I consider the example here, a set I have with the numbers 2, 4, 6, 8 and 10, where I can count the number of elements in that set 5. So I can consider this as finite set. An empty set can also be considered as a finite set because it is having 0 number of elements in it. A set which is not a finite set can be considered as infinite set, which will have infinite number of elements in it. If I consider two examples here, in the first example, we can find infinite number of real numbers between 1.5 and 10.5. So we can consider this as infinite set, and also we can consider the next one which is having positive integers from 1 to infinite as infinite set. So next thing is subset and proper subset. To explain that, I am considering two sets, set A and set B. If every element in the set A is present in another set, set B, then we can call A is subset of B. We can also say B is superset of A. Then coming to proper subset, if A is subset of B and A is not equal to B, that means there exists at least one element in set B which is not present in set A, then we can call A as proper subset of B. Otherwise you can call B as proper superset of set A. To explain this clearly, I am considering one example where I have three sets. Set A is having 3 elements 1, 2, 3, B is having the same elements 1, 2, 3, but the set C is having 1, 2, 3, 4, 5 as its elements. By observing this, I can conclude different relations here. I can say A is a subset of B, otherwise B is a superset of A. And also I can say A is proper subset of C and also B is proper subset of C. Coming to the first relation, so set A is having elements which are all present in the set B, then I can call set A as subset of B. C is having all the elements present in A as well as B. In addition to that, it is having two additional elements 4 and 5. So we can say A is proper subset of C and also we can say B is proper subset of C. By using the Venn diagram, we can represent the first relation like this. Here elements in set A 1, 2, 3 also present in the set B, then we can say A is subset of B. Coming to here, the set C is having the elements 1, 2, 3 as well as 4 and 5. Then we can say A and B both are proper subsets of set C. In other way, we can say set C is proper superset of sets A and B. The next one is universal set. Universal set is a set of all the elements under consideration, which can be denoted either by using capital S or by using capital U. In the given situation, all the sets are subsets of universal set. In other words, we can say universal set is a superset of all the sets given in the situation. As an example, in the given situation, consider two sets A and B, where A is having all the positive odd integers and B is having all the positive even integers. So in this situation, the universal set S can be represented as set of all the positive integers, which includes odd integers as well as even integers. Now we are with Jupyter Notebook. In Python, a set can be created in two ways. First one is by using two braces and the second one is by using set function. Important note is that in Python sets, duplicates are not allowed. So let me consider S1 as a set which is having the 5 elements 1, 2, 3, 4, 5 in it. Here I have created the S1 set by using two braces. We can consider this as tabular method. If I display that S1 by running this cell, I will get a set with 1, 2, 3, 4, 5 as elements. In the same way, we can get the same set by using rule-based method in Python. For that, I am using set function to create S2, and then to specify the rule, I am using a range function. Actually, the range function will take three arguments: initial value and the final value, and the third argument is the step size. So initial value is inclusive and the final value is exclusive. If you don't specify the step size, the default value for that step size is 1. Then automatically this range function will produce the values 1, 2, 3, 4 and 5, and those values will be converted as a set because of this set function. If I run this cell again, then I got the set S2 with the same elements 1, 2, 3, 4, 5. Now by using this set and range functions, I am going to create set S3 where we can find the values 1, 3, 5, which are nothing but odd numbers in range from 1 to 5. Since 1 is included in the range and 6 is excluded in the range, we will get the values from 1 to 5 with a step size of 2. Then automatically 1, 3, 5 will be the elements we will get in set S3. If I run this, I got the set S3 with 1, 3, 5. Since all the three sets are finite sets, we can find the length of those finite sets by using len function in Python. If I run this, then we will get the size of the first set S1 is 5, S2 size is 5 and S3 size is 3 now. In Python, we can create an empty set by using the set function without providing any input argument to that. Then S0 is now a null set. See, we got a set without having any elements in it. If you observe the length of that S0, then you will get 0. That means it is having 0 number of elements in it. So that's why S0 is a null set. Now we'll look at various set operations. As part of that, the first one is difference. So the difference between A and B is nothing but the set that contains all the elements present in A but not present in B. If we consider an example, A is having the elements 1, 2, 3, 4, 5 and the B is having the elements 2, 3, 4, 6 and 7. Then A minus B gives us 1 and 5. Because 1 and 5 both elements are present in set A but not present in set B. Coming to the next one, union operation. A union B can be denoted like this. Then A union B gives a set of all the elements present in A or in B or in both the sets. If I consider the same examples, then A union B gives us all the elements present in A or B or in both. Then we will get A union B as 1, 2, 3, 4, 5, 6, 7. So next one is intersection. So A intersection B is nothing but the set of all the elements common to both set A and set B. That is denoted by this symbol. Set A and set B commonly having 2, 3, 4 as elements. Then A intersection B gives us 2, 3, 4 as set. And the next one is complement. Then A complement can be denoted like this, which gives the set of all the elements not present in set A. Then we can denote the complement of A as universal set minus A. Now the elements present in the universal set S but not present in A gives us a set of elements in A complement. Complement of a null set gives us universal set. Complement of the universal set gives us null set. Both are obvious. And then A union A complement gives us the universal set. And the final one is A intersection the complement of A gives us null set. To explain this, I am considering an example. Let the universal set S is having the elements 1, 2, 3, 4, 5, 6 and the set A is having the elements 1, 3 and 5. Then we can compute the complement of A as S minus A, that is the difference between S and A. Then this gives us the set of elements which are present in universal set S but not present in set A. Those are 2, 4, 6. These are the elements we have in S but not in A. Then the next one is A union complement of A. If I consider that 1, 3, 5 union 2, 4, 6 gives us the universal set S. And the next one is the intersection A intersection A complement. If you compute that, you will get no common element between A and A complement. Then finally null set is the result of this computation. Now in the Python, I am considering set A as 1, 2, 3, 4, 5 and the set B as 2, 3, 4, 6 and 7. Then to compute the difference between these two sets, Python uses minus operator. If I run this, I got the difference set 1 and 5. So in Python, to compute the union, we have two options. So the first option is by using the operator pipe and the second option is by using the method union. So by using both the things, I am finding the union of A and B. Let me run this cell again. Then I got the same result in both the cases. The union of set A and B gives us 1, 2, 3, 4, 5, 6, 7 as a set. In the same way, to find out the intersection of A and B, the Python is having two alternates. The first one is by using the ampersand operator and the second one is by using the method intersection. If I run this, then I got 2, 3, 4 as A intersection B as the resultant set in the both cases. Then to explain the concept of complement, I am considering the universal set S with elements 1, 2, 3, 4, 5 and 6 and a set A I am considering with elements 1, 3 and 5. Then I am computing the inverse by using the difference between the universal set and the set A, that is S minus A. Then automatically the complement of A we will get in another set AC. If I display that, I will get the complement of A into AC variable as 2, 4 and 6. Now a print statement which is going to print the resultant set after computing A union A complement. Then if you find A union A complement, we got 1, 2, 3, 4, 5, 6 as set, which is nothing but our universal set. In the same way, we are going to check what is the resultant set you will get if we compute A intersection A complement. For that I am using A intersection A complement in the print statement. Then if I execute this, then we got a null set as the result if you compute A intersection A complement. So now we will check various identities in the set. First we will start with duality principle in sets. So according to the duality principle in sets, given an identity, in that if you replace all the unions by intersections, all the intersections by unions, universal set by null set by universal set, then that identity is still preserved. This duality principle we are going to use in the coming identities. The first one is commutative law. According to the commutative law, A union B is equal to B union A. Based on the duality principle, if you replace all the unions with intersections, you will get the identity A intersection B is equal to B intersection A. To prove the commutative law in Python, I have considered A and B sets like this, and then I am printing both A union B and B union A. If I run this, then I got the same result for both A union B and B union A. Next one is distributive law. So according to this, we can say A union B intersection C is equal to A union B intersection A union C. From the duality principle, we can write the same identity as A intersection B union C is equal to A intersection B union A intersection C. To explain this, I am considering three sets A, B and C. Then I am computing the left hand side of the first identity, that is A union B intersection C, and right hand side of that identity as A union B intersection A union C. Then if I display both, I should get the same set as result. Then the next one is associative law. Based on that, we can say A union B union C is equal to A union B union C, which is further equal to A union B union C. We can write the same identity by replacing unions with intersections and intersections with unions like this. Then to prove the associative law, I am considering the same ABC sets, and then I am computing the set S1 as A union B union C, and S2 set I am computing as A union B union C, and S3 I am computing as A union B union C with respect to the first identity. Then I am displaying the three sets. Then I should get the same result for all. Then the final one is the De Morgan's law. According to the De Morgan's law, you can write the complement of A union B is equal to complement of A intersection complement of B. So with respect to duality, you can write the same identity as the complement of A intersection B is equal to complement of A union complement of B. Then to prove the first identity in the De Morgan's laws, I am considering universal set S with elements 1 to 10. And then I am considering A and B sets as 1, 2, 3, 4, 5, 1, 2, 3, 4, 6, 7. And then I am computing A union B into S1. And then left hand side of the first identity of De Morgan's law can be computed as complement of A union B. Since we have A union B in S1, if you subtract that S1 from the universal set S, we can get A union B whole complement. And to get the right hand side, first I am computing the complement of A, and then I am computing the complement of B. Then I am getting a RHS set as A complement intersection B complement. Then if I display left hand side and right hand side of the first identity of De Morgan's laws, I should get the same result for RHS and LHS. Guys, that's all with sets. This is the basic introduction of the sets using the Python. So sets are very much important irrespective of your domain of undergraduation. So that's all guys with this video. I will meet you with a new video soon.